Hi there. Um, this is the 25th thing that you would need to know. And these are four things: domain, range, asymptotes, and holes. Let's start out with what domain and range are. Hopefully you remember, but in case you don't, this is what it is. Domain is simply all of the existing values in a graph or a function, whatever, from negative infinity to positive infinity. So if it is from negative infinity to positive infinity, then it's all real numbers. Now, that's not always the case if there is a discontinuity, which could be a hole or asymptote or jump discontinuity, but that's not something that is on the ACT as far as I know. But anyways, the range is the same thing, but it's just all the y values from down to up. So, oops, I still had left this on here from when I was trying to create my numbers for the problem. Okay, sorry about that. So let's talk about what is an asymptote. Well, asymptote is a thing that a graph can't go through. So if we had a graph like, I don't know, for example, a common rational equation might look like something like this. Asymptote is this thing that the graph just never touches. It's like, okay, whatever, and it goes up or down, and it just doesn't touch it. Like imagine it's like an electric fence. It will get the line will get electrocuted if it touches it. That's what an asymptote is. It could be vertical, it could be horizontal. Let's see. Well, if you factor out something, which we're going to see what that's like, and there's something left on the denominator that doesn't cancel out, then you have a vertical asymptote. And you can find it by setting it equal to 0, and we'll see how we do that. Now, there's also a horizontal one, and here's how you know if there's one. So for y of f to the p divided by f to the q. So what do I mean by this? Well, p and q are basically just the highest exponent that there is, or in other words, the degree. So for example, what I have over here, see this 2, that's the highest exponent. So that's what I mean by p. So p would be 2, q would be 2 in this case. So if p is greater than q, so if I had something like a 3, if this was a 3 and this was a 2, then there's no horizontal asymptote. If you think about it, x divided by 3 divided by x divided by 2, or sorry, what am I saying? X to the x cubed divided by x squared is x. And a graph that's x is like this. That's linear. Why would there be an asymptote? So that's why there's none. Now, if q is greater, then it is just simply at y equals 0. So that means that the graph couldn't go by the x-axis. So it couldn't go right here. So maybe it would look something like this. If there was no other asymptote, then it would just be something like that. I mean, it just never touches it. That's where the electric fence is. Now, in this case, like we have, if they're equal, then you look at the coefficients of the numerator and denominator, and you divide them, and that tells you what it is. So what is the coefficients by these things? Well, there's a 1 here and 1 here technically, so 1 divided by 1 is 1. So already we're ahead, and we know that the horizontal asymptote is at y equals 1. Don't say it equals 1. That usually makes, well, this is the ACT, so I guess it doesn't matter if you said that. But don't say that in class, because that usually makes teachers mad. Anyways. So that's one of the asymptotes. So we still need to talk about a hole. A hole is kind of like an electric fence, but it's like an electric fence that's only in one place. So imagine just like some kind of, it's really just like some electric electric pole. Imagine if there's some kind of pole in your yard and it's electric. Don't touch that thing, just go around it or go over it or something. So if a graph has a hole, then it would look like this. It has something like that. It's like there's the pole. It doesn't want to get electrocuted, so it just goes past it instead of around it because it's not a fence. So that's what a hole is, and you have one if something cancels out in the numerator and denominator when you factor. So let's factor this thing, and I will have a video about factoring, but I'm not going to explain it that much right now because this is not about that. But anyways, so this is what I always like to do because I just make them all minuses at first because then I don't have to erase it if it ends up being a minus and I made it a plus. Okay, so that's going to be 4 and 3 to make it equal 12. To make it a positive 1, we would do this because 4 minus 3 is 1. All right, here we would have 4 and 2. It would both be positive to make it a 6. All right. And by the way, like I said, the domain and range would be all real numbers except if there was a asymptote or hole. So that we're not going to say the domain and range until we know that. So we have the same thing on a numerator and denominator. That means these cancel out. So we have a hole at -4, because remember, it's always the opposite sign when there's something in parentheses. But we don't know the y-coordinate, so we have to plug it in. And what we always have to do when we're plugging it in is we plug it into the simplified thing. Don't plug it in there, just plug it into this, what we have left. So that would be -4 minus 3 is -7. Divided by, that would be -4 plus 2, -2. So it would be -7 divided by -2, that's just 7/2. So that's where our hole is. All right. So we already know that this is going to limit our domain and range because it can't go through it. It's an electric fence. It can't go, or electric pole since it's a hole. Now we still have something in the denominator that didn't cancel out. So that means we have a vertical asymptote. So we already talked about the horizontal one. What about the vertical one? Well, it's easy. All we have to do is just change the sign of it. And we know that it's going to be at x equals -2. So that means this is also out of the question, and this. So there's 4 things that are out of the question. There are electric poles or fences that make the domain and range not be all real numbers. Those are the 4 things. So there are different ways to say a domain and range, but we're going to just do the parenthetical one. I believe that's what it's called. So the domain, we're going to say it starts at all real numbers. So what's the x things? This is the x thing. This is the x thing. So it stops at -4. It doesn't want to hit that electric pole. So bye-bye. And we have to say and. And if you don't understand this, please go to Jacob Nash Algebra lessons because I explain it more. Also pre-calculus lessons, whichever one, because I talk about it on there too. Then it goes past that, and then it's, oh, now it has to stop at that electric fence, the vertical asymptote. Then it continues, and it's like, oh, good, there's no other x things that mess me up. I go all the way to infinity. That's the domain. There's all of these are parentheses, notice, because it doesn't include those values. Definitely not if it's a hole or asymptote. So in this case, it would always be parentheses. It's only going to be a bracket if it was a jump discontinuity, which, like I said, is not on the ACT. All right, range. We start all the way down at -infinity. So that, remember, domain is left to right. Now we're up to down, or down to up. Okay, what are the y things? This is a y thing. This is a y thing. So the question is, which comes first? Well, this is really 3.5, so the 1 comes first. So it's like, it stops at the horizontal asymptote electric fence. It continues, oh, and then it has to stop again at the hole. the y coordinate this time, then it's like, okay, there's no other y things in my way. I go all the way to infinity. And that there is all these things. It's not really that hard. There's not truly, there's not that many questions about this, but there could be some. So that's a good thing to know.